before we start, I want to be sure you are all with me. Adeleke, are you there? So let's go through the summary. Okay. Can you hear me? Yes, good.
Okay.
So I want us to go through the summary of what we've done to be sure that, because I'm more or less not going to teach how I taught you in ASA, but all because I know you know what you are supposed to know. So I just want to keep track of that. So we've done how to do initial setup for FTD. Why will you do that? What is the need for that?
Okay, so the need for that simply is to able to access it on the way.
Okay, to get the management IP address working. Okay, so that is the reason why you have to do initial setup to get a management IP address. You can later on change it if you put it on production, use different interface for management and all that. So I expect you to know that as you are practicing. The second aspect we did was assigning IP addresses on interface. And that one also, Kujo, why do we do that? You have ASA, why do you have to assign IP address for LAN, for WAN, and also probably for DMZ as well? Why do we need to create this interface and assign IP address and even apply security zones? Kujo, are you there? Today everybody is going to talk, so be sure you are with me with the class, okay?
Yeah, sorry, my little
Okay.
boy shouted.
Okay. So why do we have to do this? We've learned how to do this, but what is the answer to the why?
So I mean, with the interfaces, that will necessarily be we can say net of networks. So if it's the one, we know that is the outside. If it's the LAN, we know that is our internal, and the DMZ is in between the outside and the internal, and the security zones will also create the reachability. So, for instance, you can't.
Okay, so I get your idea, but let's say that will help you to determine the packet flow. So that would be the best way to answer that. So you said, so we create IP address on the interface for the benefit of creating more network, making the firewall to be aware of the network you are using for your LAN, the network you are using for your WAN, the network you are using for your DMZ, and also you create the security zone to be able to determine the packet flow. And we know that from higher security zone to lower security zone, you will be able to know that will work, but from a lower to higher will not work. So that is the reason why we do all this. With ASA, I think you asked that question, but today I'm going to go into that. With ASA, we can have specific security levels against the zone. With FTD, you can have specific security levels where you can say that 70, 50, 80, and all that. But you can create sub interface. So I'll go through that process as we are doing the NAT to show you how you can create sub interface, or you can apply different design as I'm going to talk about for you to be able to assign that. So what it means is, or let me put it this way, in terms of, let me bring the topology. So you have your topology. We have this to be our inside network. You need to apply IP address, which means that you are creating a network for the inside zone, and then you assign IP here to create a network for outside zone, and you apply security level to determine how the packet should flow. So by default, all firewall devices communicate from higher to low security zone. And with FTD, it doesn't give you the chance to subscribe security level. It gives you a chance to create zones. So you can have zones, but you can create sub interface in case you want to have multiple internal network. But mostly we do this design where you can have your core switch having static IP address to this, and then you make this core switch to be a gateway where you create so many network using your VIP IP address, and then you are going to have so many VLAN, and they are all going to communicate to this, because you have to then create a default route from here to the firewall. So that is best practice instead of creating a sub interface. So with the ASA, we did more of the sub interface, but this one, mostly with such situation, you rather have a static IP address on each, and then you define a default route to this, which we've done for this to this side. And in that situation, your core switch become the gateway to all your users, which connect your access layer switches. So that is the best option to go about that. So that is a very good answer. The next thing, if I'm to bring my interface, is also we create objects. So I show you how to create object. And creating object, we have two types. We have network objects, and then we have what we call service objects as well. And within this service object, we can also create, in addition, having a network object groups. And we've done this with ASA, and we've done it also with this FTD as well. We can also create service object groups. Now my question to Derek Tete, it's a long time I heard your voice. Why do you create network object or network object groups? Why do we do that? Why do you do it on firewall?
Perfect. Can you hear me?
Yes. Yes, we can hear you.
So we do create network objects, or I'm trying to say it. So I mean, we do create network objects just to simplify, let's say, their management.
So if this is a firewall interview questions, have you created network object before? Yes. Why do you need to create network object? You are not giving me the right answer. It seems like Roland wants to. Yeah, go ahead.
We create it to simplify and also manage configurations.
Simplify what? What do you want to simplify that you create the object? What is the reason? What will not be simplified if you don't create it?
There are ACLs and the NAT
The
groups.
ACLs, very good. This is all you have to say in an interview. So in every serious organization or every enterprise level, the ACL can be so long, or you can have a big ACL, and it becomes very, very difficult to be able to handle all the thousands of lines or hundreds of lines to be able to manage your environment. This is the reason why we create object. So for example, network object. So guys, we are almost, next week will be our last day for the class, and I'm trying to do this to be sure that you still have the concept of what we've achieved so far. Now we do network object just to represent what? Who is the name? Emmanuel. We create network object to represent what? To represent what?
Bro,
Yes?
what's the question?
We create network object in order to represent what? So this guy gave us a good answer, Derek, that we create objects in order to be able to have good management of our ACL. Because in a large environment or at your data center, you are going to have so many ACL, hundreds of lines. If you are going to use IP address, specific network, just to be doing your ACL, that would be very difficult to manage or even very difficult to troubleshoot. This is the reason why on firewall, because firewall is all about ACL. POR, you are going to open a lot of ports. So if you have hundreds of ports, then how are you going to handle it if you don't have object? So this is the reason why we create object. And my question to you now is, with that explanation, then you create network object to represent what? Give me one example.
Into like different grouping and categories.
No, that is not the answer.
Prof, I think to reduce the repeatedly using IP addresses.
So you create it to represent what? IP address, is that what you mean?
Yes.
Yes, to represent IP address of a host. So that is correct. Single, and it has to be the word single. Single host or single IP host. This is very, very important. If you are talking of network object, you are dealing with single issues. It's not object groups. So I want all of you to be able to write note, please. You can't finish this training and not get the concept of what we've done for almost 4 months now, because the answers some of you are giving is not encouraging. So write note. So it's to represent a host, represent a single network, okay? And then you can also use it to represent a single range of network. This is the reason why you do this. And that makes it very easy because you have name representing all that. So it makes it very easy to have this. Then we in that situation, and the next person is Gideon. In that situation, Gideon, then you configure network objects, object groups to represent what?
Multiple So it will be for multiple hosts.
Multiple hosts. Okay, so you do that to group multiple hosts together. Multiple hosts together, or even multiple network objects. Do you agree with me on that? Do you agree with me on that?
Yes, bro.
Okay, so you can group network object, many of them, or you can group multiple hosts. You can also group multiple network, and you can also group multiple IP address range. This is the reason why you need a group. And all these are going to support you to create your ACL and even your NAT. Okay? Without this, you can't create any policy. So on firewall, you need to understand network object well, and then you also need to know why we do it. This is very, very, very key. So you have to pay attention to that. Now we are talking of network object. So now let's go to service object. Now, service object, we create it to represent what? And that is Isaac. Isaac Botre. Is it Botre? A-B, is it Botre or I'm getting confused with your name. Isaac Botre, right? Isaac, are you there? Are you there, Isaac? Guys, let's be quick. We have a lot to accomplish.
Oh.
Yeah, Isaac. Why do we create service objects? If you know after Isaac you are next, make sure you have your mute online. Everybody is going to talk. So why do we create service object? Or we create service object to represent what? Now we know the concept as Derek told us. So in that case, we create service object to represent what? We will need it for our ACL. We understand that. But then service object represent what?
Basically, service objects is to simplify the rule that we've created to enhance like security in terms of what we have. And, so service objects are basically different from the network objects in that sense.
Okay, so the service object will represent what? What will you represent in service object? What have we said that? What did you say?
Sports. Service objects represent sports.
One of the thing is, if you jump on the call and you get it wrong, that is very, very annoying than you keeping quiet. You are not the one on the floor, and now you want to cut him, and you are even worsening the answer. Roland, relax. It will come to your end. I'll get to you, but it's not host. Why are you talking of host when we are talking of service object? You relax. I'll come to you. Let Isaac answer.
Policy part.
Let Isaac answer. He's on the floor. So Isaac.
Put it down, my friend. Prof.
Yes.
Yeah. So as I was saying, service objects represent like the ports.
The port, the protocols that you are going to use. Okay, so not a host. What are some of the protocols we have? We have HTTP, we have HTTPS, you can
TCP.
do for TCP, you can do for UDP, just about what? Protocols. Okay, protocols and ports. UDP. This is the reason why you create service ports. Okay? And this is going to be 1:1. Single. So you create service object for single protocol, not multiple protocol. If you need multiple protocol, Isaac, I'm still with you. If you need multiple protocol, what will you do?
If you need multiple protocol, then it's best you create a service object group.
Then you create the service object group. Very good, guys. If you don't get this fundamental right, then you cannot deal with firewall, guys, because you are going to read all the ingredients in this aspect. So if you want to group service object, if you want to group multiple policies or services, then you have to use service object group. This is something everybody should know by now. Okay, so we've done all this, and we've done it in ASA, and that one I explained details. That is why I'm saying this should be your summary class. I'm trying to summarize all, so you have to be able to get a concept well and be able to understand what we are doing together. Then from here, because we've done all this, because if you don't do all this, then you can't create policies. So from here we started with our policies, because now we've created a network for the inside. We've created a network we know where everybody is going. For this one, we didn't create DMZ because we've done it so many times. The same concept on ASA. That is why I didn't bother creating DMZ network. But for what we've done, once you have all this, now you can create policies. And the policies, in creating that, yesterday we spoke about creating a policy for network and services. And this one, why do we create? And when you create network and services, this rule will accomplish what? And Juliet, do you that day I think you were sick also, but let me see if you still remember or you've gone through the video. So network and services, we create a policy on network and services, and then that will solve what? What will be the solution? What do we achieve with this?
I was still going through the videos. I haven't finished watching all of them.
This one there, you've got a good excuse, even though it's not a good one, but I'll accept because we still did it in ASA, okay? But you, because you are not feeling well, we will forgive you on this. So let me see if Kenneth will support you. So I know you are not doing well, but you still came, so that is good. Kenneth, we do.
Prof, I think so we can be able to like define the specific ACL rule that we want to allow or authorize.
Are you done?
Yeah, that's what I have.
So what was your answer?
Oh, you didn't hear me?
No, I didn't feel your answer. I heard you, but I didn't feel your answer. So I want to be sure that what I heard is what I heard right.
Yeah, I said what I remember is we do the network and services so we can define the specific ACL rule that we want to allow or deny.
So if that is your answer, then why will you do ACL for URL? What would be the ACL, the difference between the ACL for this and the ACL for URL? Do you get my question? Do you get my question?
Yes, Prof.
So if you said we do this to authorize, I'm not even sure I flow with that answer well. But if that is the case, then what will be the difference between this and this? Because they are all ACL. So why will you do this and not do this if the common answer is what you said? But that is not the common answer. So if you are dealing with network and services, you are doing ACL for specific. If you are doing URL, ACL is for specific. All of them, you achieve different goals. So we spoke about doing URL, we spoke about policy for applications, we spoke about policy for what am I missing? Policy for geographical location. We spoke about policy for user identity. Very good. So my question now is, why will you do a policy and then you use this and you don't use this? Because if you don't know when to use any of this, then you can't be able to solve the issues that you have been asked to do. Did you get a question clear now, Kenneth?
Yes, Prof. I mean, with that, I think if I remember correctly, to like do restrictions. Stop.
No, policy. Oh, the baby is worrying you. That is why you are not giving me good answer. You let me bypass you. Sometimes if the case are disturbing, we can lose focus. But let me bypass you and go to Kwejo. Kwejo, but when the baby is gone, let me know so that I ask you my question, okay? Don't hide behind the scene with the baby. Kwejo, so I didn't get the answer Kenneth gave was not the right answer. I want why you do, if you, okay, let me put the question this way. Why will you do a policy and then say that this policy is for network and services? Or if you get a request and you based on the request you have been asked to do, you know that you have to, this is a request for network and services, and it's not a request for URL, it's not a request for application. So we do network and services to achieve what result?
Can I try?
So, you said we do network and services to achieve what results?
Yes.
So let's say if you're setting up to achieve, like, let's say if you want to set up a policy, right? So if you're setting up a policy, you're going to need your No, the question again. Sorry. I
Okay.
didn't catch up.
Why will
Take
you
it
do?
again.
Why will you? If you do so, we said we are talking about policies. After we've done
Right.
our network, we've created our object. It means that we are okay to set up a policy. Now, setting
Yeah.
up the policy. If you are setting up a policy for network and services, what will happen on the network?
If you're setting up a policy for network and services, what will happen to the network?
Yeah. What will you achieve? What is the end result?
That's an ACL right there.
And what is the end result? Because we have
Oh,
four,
okay. So
we
to
have
suit,
five different policy we will configure. So why will
right.
you, when you use this one, what is the end result?
I don't know if I'm understanding the question, but basically, if I'm setting a policy, I'm setting it to suit the organizational needs. So,
Okay.
based on.
And when you choose network and services, what will you use it to resolve?
What will I use it to resolve?
Yes. You create policy for solution. You create policy for solution. So
I wanted to
question is
try.
to-
You didn't give me the chance. I wanted to say that, but you
Bro,
didn't
this
give
your
me the
question is
chance.
so general.
it's so general. Okay.
Yeah, the question
Okay.
was a
Yeah,
bit.
because if you're asking me that if you create a network and then the policy, it is suiting an organizational needs. So that's the answer.
No, that is not
Right?
the answer. Any of this will
Kojo,
suit.
Kojo,
Any
no.
of this
His
will
answer is
suit.
the right answer.
Any of this
What
will
was
suit.
that?
Hold on. Any of this will suit the organizational need. Any of this.
Right.
That is why there are some firewall you can't do this. It means that not
Right.
all their need will be resolved. So my question is, if you are dealing with this, then what do you want to achieve?
So you want to achieve solution.
Okay. Juliet, you want to try? You said you want to try.
No. You said you
Ensuring
want to achieve
security?
No, security, of course. Firewall, we need security, but you guys are not giving me the right answer. Roland, let me
Can I
see.
try?
Okay, Kwejo.
Yeah.
So you are either allowing or blocking a network or a host, or you are either allowing or blocking a port or a protocol.
I think you said it right, but you box it together. So if you choose the first thing, what you are trying to do on the environment is you are trying to make sure that a network can be able to either access or deny specific service. And the word is network relating to specific services. That is the reason why you will not use URL. Because URL, you are just blocking a domain name. You are not either permitting or allowing a network on specific services. So Kujo gave the right ingredient in terms of bringing the network and also making sure that the network is either going to block or permit certain services on the network. So the reason why we have a firewall and you have 5 process for a policy is because the first one will only deal with network and services. It's not going to deal with URL. So if there is a policy for URL, that achieves different result. If it's about application, that is a different result. If it's GOE, that is a different result. So this one is just making sure that a network, it could be a host, as Kujo said, and you are making sure that that network or the host can enjoy certain services on the network. Are you all getting the concept of what I'm saying so far? Do you all get the flow of what, Kwejo, is it clear to you now? So what you gave first before,
Right, yeah.
is not the actual answer, and I don't want you to use it in an interview because they can ask you, so what are the policy you can set up on FTD and why? What are the policy you can configure on FTD and why? Why, or what will you achieve with those policies? So you give all the 5 list of policy, and then you should be able to explain what each and every one of them will be able to accomplish when you set that rule. And of course, the rule can either deny the service or allow the service. But always remember, this is mostly for POR, port open request, as I told you. And port open request means that you are allowing certain network to talk on certain port. And the port I'm referring to what? Services, which we've already spoken about, okay? Then after this one, we also yesterday did how do you call it?
Prof, are you sharing your screen?
Yes.
IDS and IPS.
Yes. Why you don't see it?
No, I
No,
only
you're
see
not
us.
sharing, Prof.
Oh, for
Okay.
a long time I was not sharing, or now? For a long time or just now?
Like some
Long
5
time.
minutes ago.
Okay, maybe there was light out. Okay, so yesterday too we did how to make sure you do deep packet inspection using intrusion detection, or how to also detect malware. So we've done how to enable this as well. So what the reason why I'm doing this is to let you know that it's just a recap of what we've done when it comes to ASA. It's not anything new. So today we are going to focus on NAT. And NAT, I'm not going to go into details like we did in ASA because you know them. What are the types of NAT we have? The types of NAT we have PAT, and we have static NAT, and then we have dynamic NAT. Now, as security guys already teaching you different vendor, I'm not going to go into details what we use this to achieve and what we use this to achieve. But today exercise, our first task is that right now we've not done any configuration that can give internet access for outbound traffic. So what we are going to do today is to configure, first of all, we are going to configure parts for our outbound traffic. Why do we need this? Without this, we can't get internet. And we've gone through the advantages of PAT, disadvantages of all this protocol. So I'm not going to go through that. So we all know why we need PAT. And this is what we use for internet access, where you can use one single public IP address to be able to achieve that. So we are going to do this. Then after that, we will create another inbound from outside. We will configure inbound traffic. So we configure a rule for inbound traffic using okay, so this one we are going to use, let's say, static port forwarding. Okay, so port forwarding. Why will we do port forwarding? Port forwarding, I've told you that the reason why we need port forwarding is when you do NAT static port forwarding, is very useful when you have a situation where you have just a single public IP address, which in this situation it can be your outside interface, and then you want to use that public IP address for multiple devices behind the in your inside network. So when someone connects to the public IP address, you can forward it with a port which is available on your internal network. And today we are going to use one of the servers to be the one that will forward the port to. So when anybody connect to the public IP address coming with a specific port, is going to talk to that server which we've allowed that port to communicate to. So we are going to create one outbound traffic and we create one inbound traffic using static NAT port forwarding and using PAT. Okay, so now let's go to our FDM, and please, what I've shown you, try and go through them item by item and make sure that you really understand what we are achieving, because next week is our last day, guys, and we've done this for long. But if you go through all the things and the answer to why, this is what firewall is all about. And once you understand this process, yes?
It looks like you've left IDS for point number 5.
I left which one?
IDS for point
Yes,
number
yes.
5.
Okay, yes. Thank you. So we have what? IDS. The purpose, even though we didn't enable it, but now we understand why we need all this on our environment. Thank you. Okay. So please go through this process and not just go through it. Make sure you understand, because this is what firewall is all about. If you look at what I'm giving you, if you understand this, firewall is going to be very simple for you. But if you don't understand this, then it's going to be difficult for you. So make sure anybody who have challenge with this, you'll be able to go through and handle this well. So what we are going to do is, we are going to do our first rule. Okay, so we are going to do our first rule for the static NAT. So let me come back here. We have our device here. So this is a policy. NAT is also part of the policy. So we go here and create a path, and we create one rule, and we are going to use auto NAT. And let's create this NAT for, let's say, outbound or internet access. Let's use it as internet access. That is the rule for this NAT. Okay, and it's saying that it will be automatically placed in auto NAT. And then you change this to be what? Dynamic. We want to use dynamic, not static, not 1:1. Okay, and then we choose our source. So our source interface is going to be what? So we are dealing with inside to outside. So we are dealing with inside. So this is going to be our inside, and we want to allow every network, so any network in our inside network and on any port, to communicate to the outside. And the outside, we are going to use what? The outside interface. So we have it to be this. Okay, and then you can see that there's translation with the part. You can use IP address or you can use interface, and it has already given us the interface already, so we don't change that one. So we keep it as that, and then we want to be able to communicate to any port outside. So mostly you make sure that every port, we control port going outside, we don't control port within. So port within by default will be open. For example, let's say user 1 want to talk to, what is the IP address for this one before I configure this. So show IP interface brief. So this is .3, so the other side will be .2. So 192.168.1. Let's say what is it, .2 on port 80. This by default will be open because it's within internal network. So everything internal should be open, but going outside or outside coming in is where the restriction comes in. So we always control our outbound and inbound, not your intranet. So your intranet, you want it to work because it's a trusted traffic. So you don't have issue with trusted traffic. They should be able to communicate to each other on any protocol that is. So by default, that will be the settings for the firewall. But what happens is your outbound and your inbound. So now let me come back here, and then we say, okay. So that seems to be good for us. Let me see if, okay, so if you look at the diagram, any source from our inside should be translated with the outside interface and to any destination. So that is the rule that we've configured here. So now we've done our part, but then we have to create ACL that should work with this part going outside. So now we come to ACL. I think the initial stage we had inside to outside, that is the one. So I can keep this one for that purpose. So now this should be able to solve that issue. So we are not going to create a new one. So if you look at this one, this is our first general rule that we created. So anything from inside zone on our internal network on any port should be able to communicate to our outside zone, and then also on any network and on any interface as well. So let me see if I didn't talk about this. Hold on, let me see something.
Prof, I have a concern.
You have what?
I have a concern. My lab is not working. It's about not 10 minutes. This is the message I'm getting. Please wait for about 10 minutes.
Okay, so let's finish, then we work on that. Okay, this one you are not to go along with me. I want to finish. That is why I'm giving you the video. So pay attention and you can ask questions. Then we can look into that. But Leonard, look through Juliet Lab. Okay, whilst I'm doing this. Okay.
Okay, Prof.
Now,
Prof, mine too.
Okay. Put it on the WhatsApp so that anybody with a lab, you should put it on the WhatsApp so that you will look into it. So I forgot, you can create a sub interface with this as well. So if let's say you have multiple internal network, you can create it from this interface because you are going to use it to configure what? The NAT. But that is not what we will achieve. So that is something I wanted you to know in terms of how to create it. And as I told you already, the best method of dealing with this in real life is to use what? IP address for the interface and make the core to be your gateway. And then the core switch will have a default route to the firewall. Okay, so that being said, we have our ACL. Now this ACL will achieve the result. We have ICMP, we have the web service. If you are not sure, you can come to the object and let's see which port is for that. So this port is HTTP and HTTPS. So that is what we have on the root. So it means that we will be able to communicate to that. And yesterday what we did is on this ACL. So these are signs for you to know that you've enabled IPS or malware on this row. So if you look at here, you see that here is gray out. But if you look at the last one, as you see over here, if you put it on it, it should have come by. It's not coming. But anyway, this will tell you that you have the rule there, but you can just go through it and see. You don't do anything, just see what is there. You can see that it's enabled and order, then you cancel. You don't apply anything. So if you want to review, you can see it that way. So it seems to be good now. So what I'm going to do is we have ACL for our outbound traffic. So I'll just apply the NAT and then see whether our translation is working with this configuration. And with that, what is the verification to see NAT translation? And Peter S., what is the verification to see NAT translation? Peter S., can you hear me?
He can hear you, pa.
Come again?
So you people are behind the scene and doing different thing altogether. I'm saying that what is the verification command to determine if your NAT is working? Hey, are you for real? Huh?
Juliet's hand is up already. Juliet, go ahead.
No, Juliet's hand is not up. Hey, Juliet's hand is up. Okay, I saw only Kenneth. Now you've made her to lower it. Huh? Peter, you don't know? Okay, Kenneth, is the baby gone now?
Really, but I can manage.
Multitask, it's not easy, but you're a good father. That is good. Okay, so what is the verification?
Show IP NAT translation.
But if you want to get detail, there is one that I show you. If you want to get the exact.
I remember.
The exact one. Yes, Kwejo, you remember. What is it?
Yeah, excellent.
Excellent. Don't forget those things, guys. Okay, don't forget them. This is taking quite some time. Do you get it?
I mean, so whilst we're having these rules, sitting at the very top, then like you probably gonna have all your traffic hitting this rule then, right?
Yes. So, but this is for inside to outside. So this is for outbound rule.
Right.
Yeah. So the outbound rule, you want it that way. Whatever you don't want and you want it to be blocked, then you can put it on top, as which sometimes it will be the case for specific reason. You can block it on top.
Right.
Yeah.
Right. Yeah.
Okay. So now let's go to test from our users to see if we can get internet. So first of all, let's see for internet first. So 8.8.8. So that is working. Let's test for ports. So let's use the same public IP that if you go to the internet on port 80, will it be able to work? So we allow 80, so that is good. So now let me end this one and let's try for 443. So 443, that is also working, so that is good thing. So now if you come to this side, which is your monitoring, you can see if what we've done is working the way we want. So we can come to event, and then we have a whole lot of stuff. So event, if you pick the first one, which is the recent one, which is 443, so we can get details from here, and it tells you who initiated the packet, where you wanted to go, the port you were communicating on, the traffic is from inside to outside. So yes, so basically everything is working fine. You can also go to network overview. Network overview will also give you idea about the access rule, what access rule you are using, the users that is coming from, the applications you are trying to access, your destination. So this is very good. Now the threat and URL will be for domain purpose, but for network and services, these are the areas you'll be checking. So you can see that on this side we are good. We have this. So this is the area that you'll be checking to be sure of what you are doing. So now let's go to details of one of them. So let me open this one. So this is the general access rule that we have, and now we have this user which is trying to access the packet to somewhere. Okay, so you see the users. You can also check applications to know what applications you are using, but event will give you everything. It gives you, this is the action is allowed, which is what we want, so nothing has been blocked. We also had port 80, which is also good, so it seems to be good with that side as well. So far we are good to go. So the next thing we will check is to see the translation. So let me come to the command prompt, but let me generate more traffic to, so let's say reply 100, and whilst it's replying, let's come to this side and then say show xlate. Let me see if, okay, so show xlate detail. Okay, so now we have our internal IP, and it's translating with the IP address for our interface. So if you look at the what we have here, devices, and then we go to the interface, or we can even check it here. Let me check it here. You can do show interface IP brief, show interface okay. I wanted to show you the public IP address, but it's acting up. So let's wait for this one to come up. And then this is the public IP. So our translation is also working fine. So we have one user and it's translating with this. So we are good to go. So that is our first assignment. So the first assignment, what we achieved was to be able to create our outbound traffic for internet access. Just for what? Internet access. This is something you might not do, it will be there already, but it's good to know. This is something that I think could be a project that you will be asked to do. So as I said before, that you can have one public IP address and you use it for port forwarding. This is a common thing that we have in the industry, because you know that static is 1:1. So let's say you have internal server and you have multiple web application. Maybe some of them are on port 80, some of them are on port 443, some of the applications are on vendor port and all that. You can just use the public interface and then forward it. That is what we call NAT port forwarding. It's a common thing in the industry, because doing dynamic is expensive, doing static is expensive, but this allows you to use a single IP address for multiple devices behind it, which is very, very good. So if anybody come up with a service of that port, the interface will say, oh, okay, I know where to forward it to, because you've created a NAT policy that forward to that port. So what we are going to do is we are going to configure that one for our inbound traffic from people outside, how they can be able to access our internal server. So this is our internal server. So we want to be able to create a policy for that. So let's go on and create another policy for our inbound traffic. And in that situation, we go to NAT and then we go to add. Okay. And as you have it here, so you have to keep in mind that for port forwarding is going to be what? Manual. We are going to keep manual. If you use auto, it's going to be something few. Okay. But if you use the manual, this is where you can have the port to forward to whatever you want it to be. And then we can have our rule set. So we can say this is for inbound traffic. Okay, and we can say that this should be before the auto NAT. So you have a way to choose. You can choose this, or we want it to be before the auto NAT. So we leave it like that. And then with that, we are dealing with outside to inside. So we are taking the traffic from outside to what? Inside. So that is what we are taking from. And then we want anybody outside, okay, coming to our interface, which is our public interface. And then we want anybody on that interface coming with a specific port. So now let's configure one port. Let's say one TCP port, port 80. So let me create one from here. And then let's say TCP port 80. So we create objects for this, and then we choose this one. We say okay. It doesn't seem to like this. Okay, then we choose that specific one. Okay, so now we have that one. And to what server? Okay, this is where you pick the server that it should be forwarding to. So we have already created object for servers. If you Okay, I'll check. So I have created object for servers. I will show you after this. And then the server is working on port 80 as well. So we choose that one as well. So basically what we've done so far is to make sure that anybody who come to that interface should be forwarded to our internal server that is listening on port 80. That is our main objective over here. So we have that one also what configured. So that seems to be good. We have our outside to inside. Any network coming to the interface on specific ports. This is the server we want to listen on. We are choosing the right port. So it seems to be good on this side. So now we need to create ACL from outside to inside. So now we have to create a new ACL, and then we can say that this new ACL should be on top. And then this new ACL, we want it to be for inbound. Okay, inbound access. So we want it to be allowed because everything from outside will not be allowed. So we are creating a rule from the source is outside. Now it's opposite from the first one we did. And we can say that any network from outside, okay? Any port, or we can choose a specific port. So we can just leave it for this port. And then we want it to be on destination port of inside. And then the object is the server. So we have the server here. Okay. So we have a rule. So we can leave it specific, open like that. So from outside with any network coming with any port based on the NAT that we've done. If it's allowed, it should be allowed to the inside on this server, specific server. Then we say okay. So let me enable login. And now we can commit to both configuration. Then we do our testing. So let's wait for it to come up. So now we've done our outbound rule, we've done our inbound rule. And this is basically the things you are going to do. Or you can be doing port forwarding to DMZ. So that is going to be outside to DMZ if the servers are on your DMZ network, whatever the case may be. You can do port forwarding if you are not using dynamic because you don't have multiple IP address. You can do port forwarding for multiple devices on individual ports. So all you have to do is make sure you specify the rule of the server and the port that you want it to be listed on. And anybody who hits the public IP address, because they don't know the internal IP address. So if they have the public IP address, the device will say, okay, you want to go with a port. Let me see if there is any device that can communicate to you on this port. Then it will allow you to what? Communicate. That is all it is.
To allow whatever
you want to allow. But right now we have only one inbound traffic. If it's not enough, then you have to set another one. That is why object is important, because we are going to see so many rules.
Right. Yeah.
Yeah.
And then the other thing is that when we set the port, I thought we used port 80. So the port will be, the internal server will be listening on port 80.
Yes.
But here you didn't restrict your port. It's coming in, or it's just the destination port that matters, right?
Yes, because right now what is going to happen is, so let me come here. But we can restrict though, it's not a big deal. But you leaving it open gives you the chance to have multiple. You don't create multiple ACL for specific port that you allow.
Ports,
yes.
Right.
That will make it easier. It's easy for you. So what is going to be happen is our outside interface is 42.42.10.1. Anybody who come with this interface trying to access this port, you are saying that it should open for the person. So you can see that it's what? Open. So with the ACL now, what the ACL is doing is saying that anybody coming outside who want to access any service on 80, as long as you have a NAT rule. Remember, this will not work if there is no NAT rule. So if you don't have this NAT rule, it's not going to listen to any port. There is no any port that is going to listen on. So it will not work. So because you choose a specific server, if you have another server, you can create another rule, then you allow whatever port you have. So what it means is for one single interface, you have so many behind the scene devices working. But if you don't go with that method, it means that you have to do like the one we did, 1:1 on the ASA. You have to allow one route to one public IP address to one static IP address. And the moment that is done, that is all. So normally internal servers, you do port forwarding. And then the DMZ, I've given you multiple options. If the company have if you have dynamic public IP address, there is no need for NAT. If you have public on this side, no need for NAT. Even when your internal devices are public, you don't need what? NAT. Now we need NAT because we are public and private. But then if you don't have multiple public IP address and you have internal servers for your customers, for your business partner, for whatever the case may be, your best choice is to do port forwarding, and that is the manual NAT, static manual NAT. Does that make sense?
So, Prof, basically you're using that same one public IP address by using different port numbers to hit it.
Yes. So that is the reason why we say port forwarding. So you are using one interface for multiple ports. So let's say you have another server that you are aligned with, even a vendor port. You can do that way. Like for example, a Bankwa situation where they have just a specific device. Now you can let them use this interface and forward it to a Mankwa device, the port that they are supposed to communicate on, even if it's 4 port, 5 port. Once they hit that interface and they want to communicate to that port, they will be able to communicate to that. Does that make sense? Okay. So, are we all getting the flow now? We are getting to the end of it.